Hi, my name is Zachary and today, along with my partner
Nathan Wong,
we will be discussing our product. So this project is fully console based. The code is fully written in and works in the Spider IDE. We didn't use any libraries, and some of the major features that we implemented are the chain rule, trig functions, and two-term multiplication and division. So now moving on to process. Now there are two main parts of a derivative, of course. So we had the user enter a variable of differentiation and an equation to derive. So by doing this, we had a preset list of operators, trig functions, formatting, etc. And every single accepted value would be classified and put into a stack. And the stack leads to the backbone of our code, which is the recursive function, which Nathan, my partner, will explain.
the core of our derivation functions is a method called recursion. As an example, Zach, could you pass me a rubber ball? Thanks. Say you had a ball that you wanted to get to 1/16 of its own size, and you, fortunately, own a very specific ball crushing machine. However, there's one caveat. Your ball crushing machine can only crush balls down to half their size. What would you do in this situation? Well, you could put the ball back into the ball crushing machine once to get a ball half that size, then put it back into the machine to get a ball half that size. You can keep putting the ball back into the ball crushing machine until you get to the size that you want. This is, in essence, how recursive programming works. You input a parameter into a function, and the function repeatedly calls itself until the desired output or amount of repetition is reached. The three biggest reasons why we have to use recursion in our code is product rule, quotient rule, and chain rule. As you can see, product rule and quotient rule inherently have derivations of functions inside their own derivations. That means multiple chain rules will have to be applied and sent back up the ladder in order to have a fully derived function. Now, what does this mean? It means that we're going to have to call on the derivation function multiple times within itself. This is the primary use of recursion inside of our code.
And moving on, we noticed that after we calculated the derivatives, there would be some formatting issues, actually. So, for example, when we were trying to take the derivative of sine x, we would yield something because our derived function would take the power down, right? So it would yield something like sine to the power of 0x plus cos to the power of 1x. And we wanted to get rid of that sine to the power of 0x. So by implementing this simplify function, and we went through a lot of edge cases for this, it would go through a lot of edge cases and it would reformat the final stack for cleaner output. Okay, so for this part of the video, I will be showcasing a couple of examples. So the first example we will use is ln x times arcsin or arctan x. Now this is just a standard multiplication rule, and this is what it yields us. And we'll put the actual answers to the expressions on the screen so you guys can cross-reference. The second one is a little bit more straightforward. It's a chain rule question, sine of cosine of sine x, and it gives us this equation. And also feel free to pause the video to cross-reference it and check if we did anything wrong. And the third equation is, this one's a little bit bigger. It's sine of tan 2x divided by arctan of x. And we get this monstrosity. And yeah, and this is sort of the showcase for our online calculator. In conclusion, we created a console-based derivative calculator which replicates multiple mathematical rules, such as the chain rule and the multiplication/division rule in calculus. Thank you for watching, and have a great day.